Welcome to Complexity Made Simple. My name is Paul Allen, and the topic of today's newsletter is hypothesis testing. One of those statistical tools that everybody looks at and says, yeah, that's not for me. Why do you need hypothesis testing? So today I'm going to introduce hypothesis testing, and I'm going to show you why. If you don't use statistical tools like this, your data will just lie to you. Everybody thinks collecting data is the answer to everything. That is only true if you know how to handle it. And one of the great tools you need to know is a technique called hypothesis testing. Okay, let's talk about why we need this stuff. Usually, when you're running any process, you're constantly trying to make some process improvement. Yeah, you're constantly looking for better settings, faster ways to do it, cheaper ways to do it. So because you're constantly going, oh, okay, I've got an idea. I know what we'll do. I'll go faster. I'll go slower. I'll go hotter. I'll go colder. I'll change the supplier. No, we won't. We'll do something else. We'll use blue ones. We'll use red ones. And you're constantly looking for better ways to work. And of course, you're doing tests, you're collecting data, you're looking at the performance of your plant, you're looking at the performance of your process, and you're trying to judge whether what you just did makes a difference. Well, what I want to do is just think about what's happening, because let's say we have a bucket of parts here. They're all identical in the sense that they were all made at the same time with the same settings. So in that sense, the process isn't going to move around here. The process is stable, and this process hit a mean, and it also had a range. Yeah, so we need to know the signal. Where did the mean land? We need to know the range, we need to know the spread, we need to know the signal, and we need to know the noise. Okay, so this bucket has a fixed signal and a fixed noise. Now, let's say you send an engineer to go and sample from this bucket. Okay, so he takes a sample, let's say 50 pieces, good sample size. Okay, out comes the 50 pieces, and of course, what does he get? He gets a distribution with a mean, with a range, which hopefully, of course, represents this blue distribution over here. Okay, so hopefully what he's trying to do is to see what's truly in the bucket. Okay, but you don't trust this guy who's fetched the red distribution, so you send his colleague just to make sure everything's okay. And he takes a sample. Okay, so he takes 50 pieces. Right, again, great sample size. Out he comes. He comes up with a distribution. Mean, signal, range, the noise. We're looking at the signal and the noise. Now here's the question. These are two samples out of a static process. They are not moving. What do you think the chances are that the engineer that took the red distribution and the engineer that took the green distribution get exactly the same result? Of course, completely unlikely that they'll get exactly the same result. In fact, it's almost impossible that they'll get exactly the same result. Now, they could be close. I'm not saying that they won't be close, they might even be close to the original blue distribution, but they're never going to be exactly the same. But this is a process that isn't moving, this is a process that's static. So here's the question. If, when the process doesn't move, the two samples are always different, if I'd made a change, so instead of sampling from, let's call this bucket A, so instead of sampling from bucket A both times, maybe I had another bucket of parts over here, bucket B, with new settings, better settings, faster settings hopefully. If when I sample from the same bucket, I always get a shift when nothing's happening, how will I ever know if a shift happened? Because I always see two different results. And it could be just two different results because I've sampled and that's the luck of the draw. Or it could be the process has genuinely moved. Okay, so that is what a hypothesis test is going to tell you. The hypothesis test is going to tell you whether you're looking at signal, you push the process into a new region of performance, or you're looking at noise. Just luck alone. The two samples are just luckily different. Now if we think about this for a second, if we constantly take a red distribution and a blue distribution and we plot the difference, let's say we go 0 here, and I'll just put it as whole numbers to make a point, +1, +2, +3. So we take a red one, a green one, we plot the difference, we get a red one, a green one, we plot the difference, we get a red one, a green one, we plot the difference, we get a red one, a green one, we plot the difference. What we're plotting here is just luck. This is just the lucky draw from the process. But of course it could be that when we do this, we get a very extreme value. Now this would be a very, very rare result. So imagine you've put new settings in the process, then what you've seen is a very rare difference between the red and the green distribution. So instead of assuming that what we're looking at is just luck, because this is the lucky distribution we're looking at here, what the hypothesis test is going to tell you is it's going to tell you this is a rare event. It's happened with your first draw. So you've got very extreme results. That's going to tell you this is unlikely to have been luck. It's likely to have been your new setting. So what comes out when we're saying rare? What comes out of a hypothesis test? Well, typically a probability value. So it tells you how rare this event is. So it might say the p-value is 0.01. In other words, there was just 1 in 100 chance that you were going to get that difference if your new settings genuinely don't do anything. So in other words, we're just sampling out of the A distribution, the blue bucket again. There was only a 1 in 100 chance you would see such an extreme difference between those two samples. Now, because you've seen it in the first test and the p-value is very low, what we're going to say is, you know what, that wasn't luck. My new settings genuinely made a difference. If you don't know how to use a hypothesis test, you think everything you do makes a difference, everything looks like a signal, you learn lessons that aren't true, your data will lie to you. If you don't use hypothesis testing, your data will lie. You have to understand this thing. You can say, I don't need to know statistics, it's not part of my job, it's not interesting, it's not relevant. Folks, every time you try and make a change to a process, hypothesis testing becomes relevant. You cannot judge the data without hypothesis testing. It tells the signal from the noise. If you'd like to know more about any of the concepts covered in this video, or any of the other concepts covered in my other tutorial videos, then here's my latest book, Drink Tea and Read the Paper. Covers everything you need to know about how to make sure that Six Sigma becomes world-class engineering in your company. Otherwise, if you'd like to get in touch with me, a little bit of help about Lean, a little bit of help with Six Sigma, please contact me on the email below.